Okay, so today we're going to talk about the transformations of functions, but we are going to be more specific and we're going to actually combine all of the transformations that we have already done. So we've done vertical stretches and compressions, we've done horizontal stretches and compressions, we've done reflections through X and Y axis, we've done translations, horizontal and vertical. Today we're going to combine all of them. Okay? So let's do a quick refresher of the things that we should know at this time. So we should know that if the number in front of our function is negative, then it will be a reflection vertically. So it's a reflection through the x-axis. If that number is also not equal to 1, so that is it's 2 or it's 3 or it's a half, then we have a stretch vertically by a factor of whatever that number is, 2 or 3 or a half. Okay, now I've given this a variable of a. So if a is negative, then we have a reflection. And if it's non-1, so it's 2, then we have a stretch. Okay, so that's the a value. So that's what's in front of the function. Now the k value, which is the value inside the function, that will be our horizontal reflection because it's inside. So if it's negative, it's a horizontal reflection, or better known as a reflection through the y-axis. If the number is not equal to 1, that is it's 2, then it will be a horizontal stretch by a factor of 1 over k. You will notice in your note that there is an error. Instead of being horizontal, it actually states that it is vertical. So I'd like you to make that alteration now. Cross off the vertically and state that it should say horizontally. So if k is not equal to 1, so that's 2, then the function will be stretched by a factor of 1 over k. Now specifically, it will be stretched horizontally by a factor of 1 over k. The next value is d. Now, if you have x plus d, then we're going to be moving horizontally because it's inside the function. And if it's plus d, we're going to move to the left. And if it's minus d, we're going to move to the right. Because if you remember, the things that happen inside the function are the opposite of what we would think intuitively. Okay? So, for instance, the k, if it was 2, it's actually going to be a half. With the plus d, we're actually going left d. If it's minus d, right d. Okay? The last value is c. C is the number that comes after the function at the end. It's added or subtracted on. If the number is added on, we're going to move the function up that many units. And if it's subtracted from the function, we're going to move the function down whatever number of units. So we know all of those separately. Now combining them. If you're going to combine the transformations, we need to do them in a specific order. The order is that we do the reflections and the stretches first. Okay? So stretches and reflections, I would usually do reflections first, then stretches. From there, you would then do the horizontal and vertical translations. So moving it left, right, up, and down. Now, sometimes that's hard to remember. If that's hard for you to remember, the easiest way to remember the order is remember how you read in English here in North America. In English, we read from left to right. So you will perform the operations in the order that you see them, from left to right. So the operations, will be conducted from left to right. Okay? So that means that we will go in the order of transformations of A, then we will do the transformations that K yield, then we'll do the transformations of D, and then we'll do the transformations of C. Okay? So we'll do A, then K, then D, then C. Now we're going to try them. We're going to start first by just doing the description. Now remember, descriptions have to be done in specific ways. Okay? So with our first function that we have here, the A value is 2. 2 will imply that there is a vertical transformation of some kind. So we know it's vertical. Now, since it's outside the function and it's multiplying, it's going to be a vertical stretch. So it's a vertical stretch, which means that there's a factor. So by a factor. And now with A, the factor is the number we see. So it's a factor of 2. So I've completed that one. I'm going to pick a different color to do my next one. Now the next value is the negative inside the function. So if it's inside the function, then it's horizontal. So this is actually going to be a reflection because it's negative. And it's going to be a reflection through the y-axis because we are going horizontally. So we're going to actually take the point and put it through the y-axis to the other side. So now we've done the negative. Perfect. Now we're going to do our next one, which is this plus 3. The plus 3 is outside of the function. So again, outside, it's going to be vertical. So this is going to be a vertical transformation of some kind. Now, it's not a stretch. We've already got that because that's when multiplying. So it's an addition. So this means it's going to be a translation. There are other words you can use other than translation. We can use transformation or we can use shift. Shift is usually the easiest. So this is a vertical shift up 3 units. UN does not stand for units. So make sure you actually write the word units. Okay? And then we did the plus 3. That is done. Now we're going to work on the next one. So the next one, we start from left to right. So the first thing we see on the left is this negative sign. This negative sign is outside the function, so it's going to be vertical. So this is a vertical, what? Oh, it's a reflection. Well, since it's a reflection, it's going to go through an axis. So we're going to go through since it's vertical, we're going to take the point and go through the x-axis. Now, since we're talking vertical and we're talking reflection, since it's a reflection, you do not actually need to state whether it's vertical or horizontal. You just state it's a reflection through the x-axis. So I've dealt with the negative. Now we're going to deal with the next one, which is the 1/2. Again, it's outside, so it's going to be vertical. Since it's multiplying, it's going to be a stretch. So this is a vertical stretch by a factor of 1/2. Okay, so now we've dealt with the half. Now we're going to deal with the last one, which is this plus 1 over here. Since it's inside the function, it's going to be horizontal. Now remember, horizontal transformations are usually opposite of what we think. So plus 1, we usually think right, but that means we have to go left. So this is going to be a horizontal translation or shift. One unit to the left. All right, and now we've done the plus 1. We are done that one. So I've got a couple more to do. So this one, we're going to start with the inside value. So the inside value talks about horizontal transformations. So it's inside the function, so this is horizontal. Since it's multiplying, it's going to be a stretch. So this is a horizontal stretch by a factor of 1 over k. Now 1 over k means that we're going to reciprocate the fraction that we see. So it's actually going to be 2/3. That one is done. So let's do the next one, this plus 2. So again, inside the function, so it's going to be horizontal. It's a horizontal shift, 2 units to the left. We've done the plus 2, so we're done that function. There was only 2 transformations, only 2 bullet points. Now we're going to do this last one, the 1/2 inside the function. So again, horizontal. Since it's multiplying, it's a horizontal stretch by a factor of 1 over k. So by a factor of 1 over 1/2, which means, oh, apparently I can't spell factor. Stretch, horizontal stretch by a factor of 1 over 1/2, which is 2. So we got that one. Now we're going to do this minus 5. Since it's outside the function, it's going to be vertical. So this is a vertical shift, 5 units down. We've done the minus 5. We've done all of the descriptors. That's how we do it. So when you're listing your transformations, always go from left to right, and then you can do the operations. Perform these transformations in the order that you've listed them. Okay, so now we've been able to describe them. Now we're going to actually perform them. Before we perform them, we should always put them in the correct order. Now, the best way to do that is to start by figuring out what each of these transformations have to do with. So this one's a vertical stretch by a factor of 1/2. So vertical implies it's one of the outside variables. Since it's a stretch, we're talking about A. So this says A is a 1/2. Okay? Vertical shift down 1 unit. Well, this one's talking about C. So this implies C is going to be -1. Horizontal shift to the left one implies that we're going to have x plus 1. And then a reflection through the y-axis implies that we're going to have a negative value inside our function. So that implies that our k value is -1. So when writing this equation, we have y equals a, then our function, then k, then brackets, then whatever our d value is, and then our c. So there's our equation for our function. Now, when asked to graph, it's always a good idea to have the equation because you have to label this function later. So we now have the title. We are actually going to perform each of these transformations. So I'm going to start with the 1/2. Since it's a vertical stretch, we're multiplying all of the y values by 1/2. So I go to each point and I look at the y value for this. So the y value for this point is 0. 0 times 1/2 is 0. Next thing I've got 3 ticks to this point. So 3 times 1/2 is 1.5. So that point goes there. The next point is 1 tick times 1/2. So it's going to be 1/2. This point is the y value of 0 times 1/2 is 0. This one has a y value of 4. Well, actually 1, but it's 4 ticks. So half of that is there. So I've completed the 1/2. Done. Sorry about that. Now the reflection through the y-axis, we're going to flip all of these points and change the sign on its x-coordinate. So that was -2. It's now going to be +2. Oops. So +2. This one's 1 away, so it's going to be 1 away. This is 2 ticks from the x-axis, so it'll be 2 ticks from the x-axis over here. This one's 1, so it'll be 1 away. This one's at 1, so at 1. Okay, so there's our reflection. The next one we're going to do is shift to the left 1 unit. Now 1 unit is equal to 4 ticks. So each blue dot is going to move 4 ticks to the left. One, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. So I've now done that one. We have one more transformation to do, which is moving everything down 1 unit. So all of the green dots are going to go down 1 unit, which means it's going to go down 4 ticks. So we're going to go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Since this is our final, we will now connect the dots. So I'm going to make sure I have my great color, connect that dot to that one, that one, to that one, that one, to that one, and that one to that one. And then of course, once you've done all that, you must label your function. Okay, so that's graphing them. So we've listed them, we got our equation, we graphed it, and we labeled it. So we're done. Stating the equations. Stating the equation, it's just like we just did. Now the thing that confused us on our quiz was when it was no longer an f, it's now an actual function. So we're still going to start off the same way we did before. So reflection through the x-axis. This implies that our a value is negative. Horizontal stretch by a factor of 3. Horizontal stretch is talking about k. So now k is going to be the reciprocal of that, so it's going to be 3 over 1, which is 3. Horizontally translated 4 units to the right. That implies that we have x minus 4. Vertically translated 2 units down implies our c is equal to, well, implies we have our function minus c, so minus 2. So to rewrite this, we have a y equals, we're going to have a radical. Now this radical is basically symbolizing f. So everything that was inside f is now under the radical sign. Anything that was outside f is outside the radical sign. So a is outside of f, so it'll be out front. So there's the negative 1. Okay, k is inside the function, so it'll go inside the radical sign. The horizontal shift goes inside, so it'll go inside in brackets. Okay, and then c goes outside the function, so it will be outside the radical. And there's our equation. Something to note, when performing transformations, you have to be careful. If you look back at the form that I showed you at the beginning, we have an a, a k, a d, and a c. K is actually factored out of the inside of the function. So if the coefficient on the x value is not equal to 1, you have to factor out the value, the coefficient, because if you don't, your horizontal shift will be wrong. Not only will the value be wrong, but sometimes the direction will then also be wrong. So if you're given a function like 1 over 2x plus 4 minus 5, you will notice that x does not have a coefficient of 1. Since it does not, we have to factor out the value of 2. So we're going to factor 2 out of this whole thing. So to factor it out, we will have a 2, then bracket x plus 2. So this means that the transformations are a horizontal stretch by a factor of a half and a horizontal shift 2 units to the left. So our horizontal shift would have been wrong in this case if we had not factored it out. So Be very careful and make sure if the coefficient of x does not equal 1, you factor out that value. So we are going to graph a function. Y equals negative square root 2x plus 4 plus 1. Is the coefficient of x 1? The answer to that question, no, because it's 2. So we need to factor. So we're going to actually change this equation. So it's y equals negative square root 2 in a bracket x plus 2 plus 1. Okay, now we can start doing our transformations. I'm going to start with the base function. So the base function is the square root function. So 0, 0, 1, 1, and 4, 2. There's our function. Y equals the square root of x. Now we're going to start our transformations. This negative causes a reflection in the x-axis. Okay, so there's our function. I'm not going to draw a line through it yet because I'm not to the end. The next point, 2. That means this is, since it's inside the function, it's a horizontal stretch by a factor of 1/2. So now each x value is half the distance it was before from the y-axis. So this was 0, so it stays 0. This one's 2 ticks, so it's going to be half tick. This one is 4, so it's going to be 2. So that one's done. Now this plus 2 means we're going to shift everything to the left 2 units, which means it's going to go 4 ticks because each unit is 2 ticks. So 2 ticks per unit, 2 units, 4 ticks. So every yellow dot's going to go 4 ticks to the left. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so we've done that one. Now we're going to do the plus 1. This means that everything moves up 1 unit. 1 unit is 2 ticks, so each green dot is going to go up 2 ticks. So 1 here, and 1 there. I have now completed all of them, so I'm going to draw a relatively smooth curve and state my equation. Y equals negative square root 2x plus 4 plus 1. Now I could also write it using this equation, but I just used the original one. Okay? So there's our transformations. Again, I'm doing the same thing that we did before. I'm just doing it in order of left to right. As I told you, colors, very useful. There's one other thing we need to talk about. Your assigned work is textbook page 129, numbers 1 to 5, 11, and 13. You have a test next Wednesday. You have a cyclic problem due on Friday, December 13th, as well as the Kaylee contest that was supposed to be due on Monday is due Friday due to an error on my part. Okay.